GM, I'm Steph. I'm a DevRel engineer at Polygon. I've met a lot of you from guilds and advocates, and I know people are excited to start IDthon. And this is the perfect session to get you ready for IDthon because it goes through the verifiers, which is what you need to create a full stack website or a VC gated dApp, which is what I'll show you today. So just as a review, we're talking about Polygon ID, and Polygon ID uses ZK proofs to let users prove their identity and things about them without actually needing to expose that private information. So this ensures privacy, and then two things that we're really excited about are freedom of expression and privacy by default. And that means that as a user, your identity is completely protected by ZK proofs and basically like math, which is super cool to me and all of you. So another recap, this is that triangle of trust that we've looked at extensively. So today we'll be going over the verifier piece. But as you know, we've already talked about the issuer. And a few weeks ago, we also did the wallet SDKs, which are kind of like the identity holder piece. But basically, the triangle of trust works because verifiers trust issuers. So it all starts with issuers. If issuers issue credentials that are bad or aren't valid, verifiers are just going to assume that they can trust the issuer. And so they'll assume that it's a good proof. So that's kind of like the key point of everything is you have to have a trusted issuer so that the verifier can trust that any information that's been proven is true. And so this is what the triangle of trust will look like today with our verifier in our application. So the issuer is this demo issuer app. You can use this to just generate test credentials for all of your applications. And you could also use a real issuer. We have some that are listed. I'll show you them in a bit, but they will actually like KYC people. This demo issuer just lets you as a user decide your birthday and things. And like I said, it's just a demo for testing purposes. But the demo issuer will issue a KYC age credential. It'll look something like this. And this will be stored in the Polygon wallet. And then I am the identity holder, and I will be able to generate a ZK proof or a zero knowledge proof to give to the verifier. And the verifier in this case is a website that's checking if my birthday was before January 1st of 2023. So basically, was I born before this year? Yes or no? That's what the verifier wants to know based on some information from the issuer. So this is just more terminology and another recap of verifiable credentials. This is the W3C official definition. Basically, a verified credential or verifiable credential is a claim or an assertion made about a subject. So that might be data like their birthday. And it has to be tamper-proof evidence or credential that is cryptographically verified. So it's signed by that issuer. And the issuer issues credentials based on these schemas. So today we'll be looking at the type KYC age credential, which has two different fields, a birthday and a document type. And both of these are integers. And this matters because any verifiers have to know the specific type when they're verifying. So let's just really quickly look at these schemas. So you can see this is a specific schema for that KYC age credential, I believe. Let's see. Oh, this is a different one. So this is a schema for coding experience, which is a Boolean. So someone either has coding experience or they do not. And then this must be the correct link that I was thinking of. Oh, this is just more schema examples. So I think there is a KYC age in this. Maybe there's not, but we'll see it in just a minute. But this is the type, and those schema examples just showed you some other types. So this is a JSON, and there's also something that's a JSON LD. And both of these file formats need to be uploaded and stored somewhere so that people can reference and say, okay, these are the credential subject properties. The first one is subject ID, and the second one is coding experience. That way, if someone is a verifier, they know that they can check this credential, coding experience, against the, or this field against the credential for the schema. Okay, yeah. So I must have screenshotted it and forgotten. So this is the actual schema for KYC age credential. And you can see it's a JSON LD, which is important for the next step when we're looking at the verifier. But you can see in the KYC age credential, there's those fields, and there's a birthday field that's an integer, and a document type field that's also an integer. So a schema needs these things so that people can check against it. And this is where the issuer piece comes in. So issuers are using these specific schemas to create the credentials to issue to users. So let's look at an example of this right now. I'll send you all this link so that you can also play with it along with me. So this is the demo issuer link, and you can just follow along and we'll create a new KYC credential. So I'm going to click sign up, and it opens this QR code. And I need to scan this with my Polygon ID app. So I've just opened my Polygon ID app here, and I'll scan the credential, or not the credential, excuse me. I'll scan the authorization QR code. So this is saying that self-hosted demo backend platform wants to connect to your wallet. So it's asking if it can connect to my wallet because it wants to know what my DID is, or my decentralized ID is. So I'm connecting, and it's authenticating. And once it's authenticated, I should see, yep, here is the claims creation. So again, this is just a demo issuer. It's not going to issue you real data, but I'm going to create a birthday claim for myself. So under create claims, I need to select a schema. There's 3 that are easily available. The first one is the age credential. That's the one we're going to pick. The second one is country of residence credential. And the third one is custom. You can use custom if you want to issue a custom type of credential to your users. But let's go with KYC age credential just to make it easier for ourselves. So as you see, there's a bunch of fields that just auto-filled because we chose this one. If you chose country, it would be slightly different. You can see there's country codes and document types as the field for this one. And then custom leaves the URL and the JSON data blank. So you would have to upload your own URL, schema URL, and also specify the JSON that you want in that schema. So let's look at the age credential one more time and check out the URL. So I'm just going to open this in a new tab. And this is that same raw GitHub URL that we were looking at before. Okay, so we're back in this JSON file that has been uploaded. These are hosted by ident3, which is the Polygon ID team. They host some of the more common schemas like KYC age credential and also KYC country of residence. But like I said, you can use the same format and create your own schema as long as it's uploaded somewhere that everyone else can reference it so that other issuers and verifiers understand, okay, this is a KYC age credential or whatever your specific schema is called. So this one is a KYC age credential. And it has an expiration date. You don't need to add one if you don't want to, but things that might want to have an expiration date could be things like, let's say you're in a teacher's class and it's only a 6-month course at the university. So you want to say, I'm expiring from Mrs. Puff's class on 6 months from now. So you would add an expiration so that if there was specific content that she only wanted you to see while you were in her class, you wouldn't get it the day after the expiration. But since this is a birthday, I don't think we really need an expiration because your birthday is never going to change. So the default birthday here is 1996-04-24. I'm going to change it to, let's see, I'll change it to 1992-01-24. And this is not my real birthday. I just decided so that we'd have a demo. And then document type, I'll just leave the same. So I'll submit this and it'll create a claim. So I'll scan this with my Polygon ID app. And it's asking if I want to add a KYC age credential. I can either accept or decline this. And just so you know, this is still kind of like issuer specific, but we'll get into how to verify this verifiable credential next. So It's added my credential to my Polygon ID app. And now if I go into my data, I should be able to see that credential. And sure enough, my birthday inside of my data in the app is January 24th, 1992. And it's been issued by that self-hosted demo backend platform, which is just this issuer site, and it was issued today. And I can also see the issuer DID if I want to. That's just the ID of this issuer, because even issuers have to have DIDs. Okay, so now I have this credential. It looks something like this. It's in my Polygon ID wallet app, and the wallet is what will interact with any verifier websites to share the ZK proofs based on all of the different verifiable credentials that are in your wallet. So this is just kind of what it looks like as you're offered the credential. And now let's start to talk about verifiers. So Verifier is a Web 2 app or a Web 3 dApp platform that wants to authenticate users based on credentials before giving them access to any type of data or access. So there's two main proof request types. The first type is a private proof, and the second type is a selective disclosure. We've been talking about how Polygon ID keeps all of your data private, and it does unless you do a selective disclosure. But first, let's just define private proof. So a private proof is most queries, and in most queries, your personal information is never revealed. Instead of revealing your exact birthday, people would just be querying based on like less than, greater than, that kind of thing, or not equals to make sure that the birthday is a specific age so that you're older or younger than something. So I think of a private proof as being a bouncer at a bar. So private proof is saying, I don't need to know your exact birthday or that exact data, but are you older than 21? It's just doing a check against that information without needing the exact information. So all of your data stays completely private. And that's what most of the queries that you'll do and the proofs that you'll generate will be, private proofs. There is a different kind of proof, and it's called a selective disclosure proof. And a selective disclosure proof happens if you're checking that information is exactly equal to something. So I think of that as going to Starbucks on my birthday, and the barista says, is your exact birthday today? I need to know today is your exact birthday so I can give you this free coffee for your birthday. And I know that that example isn't quite perfect because the barista doesn't need to know the birth year, but they do need to know an exact match. So if you're doing a query with an exact match, you're asking someone for the exact value of that data. So it's no longer made private because you're saying, you know, if you're actually getting an exact match for that data. So we're going to use the first type, selective disclosure, to generate some proofs on all of our claims. And today that claim will be the birthday claim. So here's some code that you can use. You can use this for off-chain checking and also on-chain checking. The on-chain checking is the example that you've seen a ton. It's that birthday example that creates the ERC20 tokens. So if you are only interested in on-chain, you can feel free to just check out the tutorials that already exist for that. There's some really good ones on the Polygon ID site. You can scan that here. But today we'll be focusing more on off-chain because I think it's an interesting user flow and it has pertinence in like Web 2 and Web 3 because it's just some API calls. And that's what we're talking about, the Verifier SDKs. So let me just go to the APIs for Verifier SDKs. And then if you were interested specifically in on-chain, you can just go to the on-chain. But let's start here. Let me send you all the link. Okay, so these are the SDKs for off-chain verification. This kind of shows the user flow. I am not good about architecture diagrams for whatever reason. I have to see a direct example to understand things. So let me start by showing you an actual site that's doing verification, and then we'll talk through every piece and what's happening behind the scenes with the SDKs. So I created something called birthday gated website. Let me just send you all the link. So this birthday gated website is gated by a verifiable credential. You have to prove your access rights in order to see the secret content or the content that's behind the gate. So I'm going to click prove access rights, and a scanner comes up with a QR code. So I'm going to use my Polygon ID app QR scanner to scan the code. And it says VC birthday server requests the following information. It's asking for a private proof, and it's asking if my birthday is smaller than January 1st, 2023. So basically, was I born before 2023? And I was. So I'm going to hit approve here. And now the app is generating a proof request to send back to this website. So once it sends it, the website can check the proof. Okay, you can see it's authenticating, and it'll tell me whether it's valid or not. Usually doesn't take this long. I think my Wi-Fi is a little bit bad today. There we go. Verified proof successfully. And now you can see the super secret VC gated content, and it's just a meme about privacy. So users should love apps that give you access rights without giving up private data. And you can actually build this yourself by forking some code. And so I'll send you that code in just a second. But let's walk through exactly what's happening from an API standpoint. So there's two APIs that are being used. There are the request APIs and the verification APIs. The request APIs are the ones that are getting this QR code. So let's look at the request API and figure out why I got a QR code by using the request API. So the request API can either be a basic auth request, or it can be a query-based request. Since my website doesn't really care what someone's DID is, I didn't do an auth request, a basic auth request. I did the slightly more complicated query request. So that query request has the birthday credential that I wanted, and I'll show you my code. But first, let's understand the proof request. So it has the specific type. In this case, it's KYCH credential. It also has the context, which is that schema we looked at. It's a specific type. This time it's JSON-LD. And it also has the credential subject, which is birthday. Remember, we had two credential subjects, birthday and document type. And then it has the query. So the query is less than and a specific day. Once I send in a request to the request API, it will send back the body, which contains this query URL. So let's look at that in the code. So the code has a front end and a server. We're going to look at the server. And in index.js, you can see that we have two different API paths. We have getAuthQR and we have handle verification. So getAuthQR is what we'll look at. So this is what's actually sending the authorization request, which is that auth request API. And it's actually the same API, whether you're doing a basic auth request or a query request. It just depends on what you pass in. So I'm creating an auth request with a reason, which is just a human readable reason. My reason was must be born before this year. And that can be anything you want it to be. Also, I'm passing in my verifier DID. That's just the DID that I'm using for this service, and a URI, which is a callback URI. So this is what I'll send back. So once I get the QR request, you can see it comes back with the scope and then the proof request. So I'm sending that to my front end. And on my front end, I'm actually running some socket events just so that I can see what's coming back from the server in real time. But once I have that query-based request, I can use the response and put it in a QR code. So let's go to the front end. I created a custom component on the front end called Polygon ID Verifier. This is what's creating the modal with the QR code. So the QR code is right here, and it's just waiting for that get QR code API, which is calling the backend, and then the backend actually makes the API call. And that's what is getting the data in the QR code. So if we go back to the website and you inspect the QR code, or actually if you kind of hover over it, it'll start to show like the data. Usually it appears towards the bottom of the website, but for some reason it's not showing up right now. So let's just check the network request. So these are all of the sockets that are pulling, but you can see that the get QR code request is actually already right here. Let's look at the preview. So this is what's being sent. There's a body from the server, and it's that reason message, must be born before this year. There's a callback URL that is the callback for the server. And then there's a from and an ID. And all of these are just set right now to the session ID so that I can track if the same user has requested as the server is, because there might be multiple users requesting at the same time. So this authorization API, or the query-based request, is the one that creates the QR code that deep links to the actual query request for the birthday. So that's the first half, that's the query request. And the second half is the actual verification. So the verification happens by callback. Remember on the website, you scan this QR code and then things happen on the phone where it starts to say authenticating. And then once it's actually authenticated, we get a response that says valid. So let me just run through that flow one more time so you can see the actual response. And we have the network tab open because we're waiting for a response from the server. Okay, so it's authenticating now, and we should see a response in just a minute from the server, and that is the response from the verification API. Okay, where is it? Might be this right here. It's a little hard to see all of the actual responses. Let's see if okay, so I can't show you the exact response in the networks tab, but we can look at the code for it. So remember with the QR code API, we were sending back a, where was it? Okay, so this is the verification callback. So it's looking at the QR code API, and then this is the handle verification in the server. And the verification is checking against the actual proof, and it will send back whether or not the user has successfully authenticated. So this is the full verify API call. So we're just calling verifier.fullverify, and we have a token string, an auth request, and some options. So let's look at the token string first. This token string is what has come from the request body in that QR code. So we're grabbing all of the different things from the request, And then this is the auth request. And this is just a value based on the map. And the auth request is specific to the user. So that was what I was talking about when I said the server can handle multiple auth requests at the same time. And that's because we're passing a socket ID back and forth from the front end. So any of these requests will have a socket ID to make sure it's this one. It starts with like AOU to make sure that it's the same user that submitted the original request. So back to verification APIs. So verification can only happen after there's already been a request presented with that QR code. Once there's a request in the Polygon ID app, it looks at the person's wallet and checks if there's actually some data that's pertinent to the request. So if there's a KYC age verification VC, then it can start the verification. So I'll just find that function for you. Okay, so full verify. So this is just more information on the actual verifier. So you can see that there's a full verify request going on here, and that's just executing that same verification against the token string, the auth request, and any options. This option is just to specify how long of a delay can still be verified. So this one is up to 5 minutes. And then I think there's other information about this. Yeah, you can look more into verification under the hood here. So those are the two main APIs, the authorization or get QR code API and the actual verification API. You need both of these to kind of have a full flow of verification off chain. So let's look at the code for this repo. I actually created a template today for a hackathon that's going on. So you can check out this full stack repo if you want to. This has the front end code and also the server code that you'll need to run a verifier. So first you'll set up a server and then you'll set up the front end. This is everything that you need for the server. So again, like we saw in that demo application, the server is using socket polling. And the main purpose for sockets is to have session IDs specific to the user so that you can pass them between the server and the front end and understand like sessions to keep those clear between users. So the server works by using those two APIs, those two verification APIs. The first one is the query-based request, and the second one is the actual verification of the proof. So if you wanted to set up the server, it's super easy. All you do is create a template or create a repo from this template, and then you cd into server, install all your dependencies, and then you add a few things to your .env file. The most important one is the RPC URL. So make sure that you're using one from like Alchemy or Anchor. For some reason, I noticed the public RPC endpoint for Mumbai wasn't working for this app. But so instead, I just used an API key from Alchemy. It was completely free. You can change the verifier ID if you want to. If you want it to be specific to like the one in your wallet, you can do that by checking your profile and then using the identity that's in your wallet, but you don't have to. And then eventually when you're referencing the front end, you'll add the front end URL, but don't do that quite yet. You can run this by just running npm start, and it'll start the server on port 8080. So let me show you what that looks like. Okay, so this is, I'm just going to clear all of this. I have everything installed, and I'm just running an npm start. You can see that it started running the server on port 8080. So let me just show you localhost. And there is the Polygon ID verifier server. This doesn't look very interesting because it's just the server where you'll make your requests. But you can see there's two routes available. The first one is that authorization route, so get auth QR. And the second one is the verification API, so get verification callback. And the other thing to note is that when you're running your server, you need to set up server forwarding with ngrok. So I already had it installed, but all that's happening here is that with ngrok, I'm pointing my localhost 8080 at a public URL. So this is the public URL that's mirroring anything happening on my localhost 8080. This is important because the Polygon ID app, like the actual mobile app, doesn't know about your computer's local host. So it needs a publicly available URL, like the one you get from nggrok, in order to send you the callback URL. So the callback will come from this public URL. So if you visit this site, it should look exactly like localhost 8080. So this is the nggrok link, and this is 8080, same content. So once you have that forwarding address from nggrok, mine starts with FB46, you'll add that forwarding address in your .env file. So my .env file looks like this in my server. And you can see that I've already updated my hosted server URL with that nggrok link, and that's why it's working all of the way through. So I've been showing you a lot of birthday examples, and you can use birthday examples if you want, and the field can either be birthday or document type. But if you wanted to do something different, you could grab a different schema that has that somebody has issued out, and then check against that. So these are a couple more examples of the birthday requests. So this is birthday equals, and then this happens to be Taylor Swift's birthday. And this one is document type is greater than 420. So those are just two different requests. And if you remember, this second request would be a private proof because you're checking greater than. And this first request would be a selective disclosure because you're checking if someone's birthday is equal to this date. And then this is the default proof request. This is what the app is currently using. It's checking if the birthday field is less than January 1st, 2023. This is kind of just what it looks like on my phone. And the other thing to point out is that this was using a credential atomic query SIG v2 circuit, which is a complete mouthful. But these are the different things that this circuit is verifying. First of all, it's checking if your user, so your DID, is an actual owner of a VC with that type. So you can see here that it says from KYC age credential. So it's checking, the first thing it's checking is that you actually have a VC with this type. After that, it needs to check that you are actually the subject of the claim. So it belongs to you. The DID matches the DID you're scanning with. Next, it's checking that the claim was actually signed by the issuer. In this case, the issuer is, I don't think it knows who it is, but it's checking if it was signed. Next, it's checking that the schema matches the one in the query. So it's checking that there's an actual birthday field. Then it's checking that the claim has not been revoked or it's not been expired. Remember, we didn't have a specific expiration for this claim that we created with the claims list. I don't know if we can see the full thing. Yeah, there's no expiration field in that claim. So we're good to go there. And then the last thing is it's checking that the actual check satisfies what your data is. So remember, our check was this one, less than 2023-0101. So that's the last thing. First, it's checking all of these other things to make sure that it's a valid VC and that you own the VC and that it's been signed, all of those things. If you've got all of that and you also pass the check, then your proof is like authorized all the way through. And the auth response for that returns the DID doc and some other fields. So that's what the server is doing. The server is the one that's making those two API calls to the Verifier SDK. And this is one last step that you can do if you want to. It's basically just like hosting the server. So I think you saw all of mine is actually hosted. So I'm hosting my front end on Fleek, and then my back end is hosted through a service called Render. It's not a decentralized service, just so you know. It's centralized, but you can check out how to do that. Basically, it'll have you store all of your .env variables somewhere, and then it'll give you a link so that you can show all your friends your server. And the other thing to point out is that because we're using a front end and a server, you might run into CORS issues unless you specifically like allow list the local hosts. So let me just show you how I did that in my server really quickly. So one of my requirements, my dependencies is CORS, and I'm using CORS to allow list a specific origin front end URL. And that front end URL is defined in my .env file. So the front end that is like allow listed for CORS right now is localhost 3000 when this is running locally. And then once it's hosted, I'll change this to the actual birthday website so that the CORS issues don't happen in production. And then a little bit more info. If you use this repo, you'll notice that there's a keys folder, and this has all of those different verification keys that are necessary to verify a ZK proof. And it also includes verification instructions in case you want to like make sure these keys are legit. The Polygon ID team did a trusted setup ceremony where they basically like generated all of the secrets for these keys, or not the secrets, but like the hashes. So you can check those, or you can just trust me and use the repo. But there's 3 different circuits. There's the auth v2 circuit, the atomic query MTP, and the atomic query SIG off-chain. Okay, so that's the server. Let's just get into the front end as well. So the front end is the actual website or dApp that has the VC gated code. So it's requesting from the server to make sure that everything is good with the credential. And that's what we just saw hosted on the birthday site. Oops. So I created this template. I'm just calling it like a full stack Polygon ID gated dApp template. And the purpose of this is to just give you all of the starter code you need to have a full stack gated dApp. And then it also even goes into the dApp part. But if you already have the server, then you're good to go to start with the dApp. It's a little bit opinionated of a setup just based on things that I like. So I was using React on the front end and then Chakra for component styling. So like getting the box component, getting the button component, having links, things like that. And then since this is set up to gate a dApp, it's actually set up with RainbowKit ahead of time so that once you pass your Polygon ID verification, you'll have a setup dApp example. So in order to run this, you'll follow all of the server setup instructions. One thing that I couldn't get, and maybe one of you can kind of like help me out with this if you want to do an open source commit, is the legacy peer dependencies flag. Wallet Connect is migrating right now to V2, and they haven't like, they're still using some legacy dependencies. So unless you use this flag when you install, you'll get some errors. So I just recommend installing all the dependencies on the front end with this. And then if you add any more, just make sure you pass that flag. But then you'll create a .env file on the front end. You can just copy my sample. And it's just pointing at the backend local host server, which we saw was 8080. And then also the public server, which is that nggrok server. And the last thing you need for this is a React app Wallet Connect ID for the actual dApp that you can create behind the credential gate. So let's take a look at the VC gated site. I'm running this on localhost right now, and it looks almost exactly like the site we were just looking at. I've kept the template one white and then the other one black, just so that I can distinguish between the two because they look very similar. But this is the VC gated template. It's also using the birthday credential. The only difference is that behind this is a dApp. So if you prove access rights here, you'll be able to see a dApp. So I'm just scanning the QR code. It's requesting information from me and verifying my proof for the birthday credential. It's still just loading. And now it's authenticating. It was successful. It verified the proof. And now you can see this is what's been standing behind it. So instead of the meme on the other page, this one is an actual VC gated dApp. So this dApp lets you connect to Polygon ZK EVM. So I just connected. This is my Rainbow Kit wallet. So you can see it just makes it super easy to log in and out. And the two networks I'm allowing are ZK EVM testnet and Polygon Mumbai testnet. So you can actually see the connection information. I don't know about you, but when I'm developing a dApp, I'm always like, wait, is my address actually connected? What is the public client referencing? All of that, those small details are up here so you can see them. And this is just a counter dApp. It's a really simple application that's connected to the blockchain. There's only two functions. There's retrieve and increment. So basically, this is just trying to show you how to read from a smart contract. So it's reading the value of 17. And then since I'm connected to Polygon ZK EVM testnet, I can actually write to the smart contract as well. So it's just updating that counter, and you can see this is the new count. And this is cool because, like I said, it was all gated by our Polygon ID credential. So unless you have a birthday credential that is less than this date, you'll never be able to see that counter dApp. And the counter dApp is like not that important, right? It's mostly the idea of this private verification. So like I can only see that private dApp because I had this birthday credential, but this application, this web app, doesn't need to know my birthday. And that's pretty revolutionary because like if I were to go to like, let's say a beer website or something, they would say, what's your birthday? And check that against an age. And obviously you don't have to give your real birthday on a website like that. But imagine if you did, you'd be giving up private information. Or maybe you actually put in your real birthday and you're kind of giving up private information. This is cool because this is just an example of how you could ask users for something that you can check against without actually needing to know their real birthday. Okay. So that was a big demo of off-chain verification. I'm going to post this template link one more time just so that you all have it. And then we only have 10 minutes left, so we'll look really briefly at on-chain verification. And let me know if you end up using the full stack template. I think it's the perfect start for the IDthon Advocates Challenge because it has everything set up for you, and then you can just modify the type of schema that you want, from birthday credential to anything else, whether it's like country check or is good at coding check, anything that you've created, you can check with this front end and server. Okay, so the last thing that we'll talk about really briefly is just on-chain verification. So let's go back to the docs and I'll show you on-chain verification. So this was that implement an ERC20 ZK airdrop in 20 minutes. The main difference with this is that there's not like a super friendly front end that you can use because all of the actual polling is happening in the smart contract. So you would have to set up specific watchers or something, but you can implement this if you want to, and it'll check on chain against the contract. So if we go to the very bottom, we can see how it actually works. So a user claims the ZK airdrop by just scanning this with their QR code. It checks the birthday credential, and in your wallet on your phone, it will redirect you to MetaMask to actually mint the tokens. I've already minted them with my address, so I can't, but let me just show you. So this person in the video is going to generate a proof. They're generating that same KYC age credential we did a bunch today. And then let me just speed it up a little bit. Okay, so this is the important part. Once they've generated the proof, there's a handoff to MetaMask directly on their phone. So it's asking them to open their wallet. And so I think they'll choose MetaMask probably. MetaMask is the slowest loading thing, I swear. Okay, so they're connecting to their MetaMask. It's generating a proof. And then if the proof that's generated is properly authenticated, they'll get to mint this special ZK token. So this is what it looks like as they're minting, and they'll confirm that transaction, and the token will actually be added to their wallet. The reason that I showed you the video rather than a demo is you can't see my phone in this share screen. So it's not really that interesting to watch me just like scan this QR code and be like, it worked. So you can just watch this video for on-chain. Ooh, yeah, I use Plug ID Thon because it's exciting. I just saw the messages in the chat. Okay, so coming back to the on-chain differences, when you're doing it on-chain, you design a specific smart contract, and then you implement ZKP Verifier, which is a separate contract. Let's look at ZKP Verifier. So yeah, so there's a couple interesting hooks in ZKP Verifier. The first one is before proof submit, and the second one is after proof submit. So before proof submit is where you would add any specific logic that you need from your smart contract. So the before proof submit for the ERC20 makes sure that the sender's address is equal to the address of the proof so that you're not verifying with someone else's proof. And then the after proof submit is a second check, and that's a hook on the ZK Verifier smart contract. And this check is just another logic check for our specific token. And it's that we don't want the same person to be able to claim the airdrop more than once. So if you've already claimed the airdrop, if your address to ID is already present, you can't reclaim the airdrop because it already exists in the smart contract. So the smart contract knows like, oh, okay, this person already has the token, so they shouldn't get to just infinitely claim and take all of the tokens. So you can only do this exactly once after you verify. Yep. So this is where that is implemented in the ERC20 that is created on the on-chain verification smart contract. And so after you deploy your smart contract, you also have to actually add the conditions for your proof. So first you deploy a smart contract, and then the second step is setting the ZKP requests. So this is really similar to what we were doing with the QR code in the other example, where we were saying, okay, we want the user to be born before 2023. And you do the same thing when you set the ZKP request for your smart contract. The only difference is that the query language looks a tiny bit different. So this is the query language example for if you're doing this on-chain. Instead of saying the $LT, you would do an operator, which is a value. So the operator for less than, if you are sending this to a smart contract, is 2. And then these are all of the other different operators. And then the value that you're comparing it to is passed into this values array, which is within the query. So you would say basically the query takes schema big int, which is kind of like a hash of the schema. And you can actually figure out that hash with this nice little Go playground. I'm planning to implement this in JavaScript too, so that you don't have to open the playground in order to upload your schema. But you can see this is where someone has uploaded the schema, and the result is that hash. That's the schema big int. And then the other thing is the schema claim path key. So that's also created in this Go library or this Go playground. So you can paste your schema into here and you'll get those 2 values, or you can do it with JavaScript. You just have to transform some values. Just so that you don't get it wrong, I would recommend just doing it in the Go playground because it works and it's already there. But then you have the request ID. I was setting this request ID to the session ID. And then the query has those two schema hashes basically, and then it has the actual query. So the operator is less than, which returns 2. And then the value is the date value that you want to check against. And then because you're passing this back into the smart contract, you have to specify the verifier address, which is just the return statement of like the contract you deployed. You can just get like contract.hash. And then after that, once you've posted this ZKP request, you'll be able to verify with the actual QR code in the airdrop. And then for this QR code, it looks kind of similar to the one that we were playing with in off-chain. It is just that same type of QR request. The context is the schema that we were looking at, the birthday schema. And you can see, because this QR code goes on the front end, we're using that same query language that we used before with the $ syntax. The only time you use the operator syntax is if you're passing the different operations into a smart contract, because it understands these integers rather than strings. So this was the front end for the on-chain example. I think it actually is almost exactly like what we did before. The main difference is transaction data is added. So in addition to the query, since this QR code has a value that's passing off to a smart contract, we have to add the contract address where the ERC20 is, because that will be kind of like the handshake or the handoff between Polygon ID and the smart contract. So it's looking at contract address and then method ID, which you can just get from the verified contract. And then chain ID and network are Polygon Mumbai, which is our Polygon testnet. And that's pretty much everything. I'm really excited to see what you all build during IDthon. You can take all of these ideas and kind of extend them to your own logic and turn them into anything you're building, anything that you want to query against where you need privacy. You can create an issuer, issue credentials, and then verify them with this code. Okay, I'm just going to go back to the slides for 1 second. This is a link to these specific slides. I dropped a bunch of actual code links inside of the Meet in the chat. So I'll send those out on the Telegram, but I think you should have everything you need to successfully start IDthon. If you don't, or if you have any questions, feel free to ping me on Discord, on Telegram, or on Twitter. I'm Steph, and thank you so much. I know that we didn't get to do this session last week, so I'm so glad you all came this week.